we're going to learn to calculate something called a formal charge. Calculate a formal charge. You take the valence electrons minus the electrons in the Lewis structure and that will give you the formal charge. When I say valence electrons, guys, I'm talking about when we look at the periodic table and we say carbon's got 4 valence electrons, I'm talking about that number. Okay, so the valence electrons is talking about what the periodic table gives you. The electrons in the structure, that can be kind of tricky if an atom has dots on it. Like if we go back and look at this oxygen we drew. If we consider this oxygen on the left side, how many electrons does it have in that structure? Well, it has 4 dots, okay? But the bond, we've got to split those electrons in the bond between the 2 oxygens. So in other words, each bond you would count 1 time for that oxygen, and you're then going to count them 1 time for the other oxygen, okay? So if I were counting up the electrons in the Lewis structure for this oxygen, I would count 2, 4, 5, 6. And then when I go to the right oxygen, I'm going to split the electrons in the bond. See, 2, 4, 5, 6. So I'm counting all of them up, but 2 of them go for this one, 2 of them go for that one. Does that make sense?
So should it always add up to like equal 12? Or?
Yes. When you're subtracting out the number in the structure, it should add up to be the total if you do every single atom. Okay? And then you just subtract those numbers and that gives you the formal charge. Now, since I'm talking about oxygen, let's calculate the formal charge for each of these oxygens. And I can go ahead and tell you it's going to be the same because they both look exactly the same, don't they? How do I calculate formal charge? Take the valence electrons. The periodic table says that oxygen should have how many valence electrons? It should have 6. How many electrons does this oxygen on the left have? It has 6. Do you see that? 2, 4, half of those, 5, 6. So this oxygen has a formal charge of 0. The oxygen on the right has 2, 4, 5, 6, has a formal charge of 0.
Does that have anything to do with like them being in their natural state? Like when we do the combustion,
it was 0. Okay. No, actually it doesn't. It doesn't. But you can relate formal charge to electronegativity. They're not always going to turn out to be 0, but you can relate it back to electronegativity. Let's look at the one right above it, the NF3. How many valence electrons should a fluorine have? Do you guys see that the periodic table says every fluorine should have 7? Yeah? How many should a nitrogen have? It should have 5. This fluorine over here on the left, how many does that structure show that it has? It shows that it has 7. Right, because the bond I'm splitting between the 2 of them. How many does the fluorine on the bottom have? The fluorine on the right. The nitrogen on the top. So everything in that structure has a 0 formal charge. Sometimes Lewis structures can get very difficult. We've drawn very simple ones. If everything balances out to be a 0 formal charge, that's good. It wants to have a 0 formal charge. Is that always going to be the case? No. Y'all, sometimes there's going to be negative ones and zeros and plus ones, and it's still the Lewis structure. Okay?